G'day guys, we've got an exam question today which is going to require us to use the method of u-substitution when integrating this weird looking function here. Before we get started guys, just a quick favour, if the video does end up helping you, please hit that like button. I'm only a small channel, so if you'd like to subscribe, it really will help me get my videos in front of as many eyeballs as possible. And for those that are interested, I've created a PDF with a fully worked solution to this problem. A link to that PDF will be available in the description box below, so if you'd like to check that out, be my guest. So let's get to it. The question is asking us to use the substitution u equals cosine of 2x to evaluate exactly the definite integral of this complicated function here. Now when I'm doing integrals, especially integrals using u-substitution, I've got a checklist of a series of points that I like to go through to make sure I don't miss any of the key steps while evaluating these particular integrals. Okay, so the first step is to identify an appropriate substitution. In this problem, they've provided that substitution for us in u equals cosine of 2x. So step one has already been done. So let's give it a little tick. Now the second step is we have to differentiate our substitute to find dx. So what we're going to do is we're going to differentiate u with respect to x, and then we're going to rearrange that derivative just to have it in terms of dx. So we have our substitute, u is equal to cosine of 2x. Now we're going to differentiate that with respect to x, i.e. du dx. And we have a simple chain rule. The derivative of cosine is negative sine, and the derivative of 2x is just 2. So our derivative total will be negative 2 sine of 2x. So step 2 asks us to differentiate our substitute, but we have to find dx. The reason we're going to do this is because we're going to need to substitute in for dx in our integral. So we're going to have to evaluate this in terms of du. So we're going to take dx to the right hand side and negative 2 sine of 2x to the left hand side. Cool, so now we have our substitute for the dx part of this large integral here. And with that, we have finished step 2. Okay, in step 3, we're asked to evaluate the substitute at the endpoints of the integral, i.e. u of 0 and u of pi on 4. So the reason we're doing this is because if we're going to substitute something into this problem, what we also need to do is we need to figure out what the equivalent endpoints will be for this substitute. So let's start with u of 0. It's going to be equal to cosine of 2 times 0. Now cosine of 2 times 0 is still the same as cosine of 0, which is equal to 1. Our next endpoint is pi on 4. So we're going to find what our substitute is equal to at pi on 4. So u of pi on 4 is going to be equal to cosine of 2 times pi on 4, which is equal to cosine of pi on 2, which you should know is equal to 0. So now we know what our endpoints are going to be once we do the integral of the function post-substitution. So let's go and tick off number 3 from the list. Okay, so for step 4, we're asked to substitute u and du as well as the new endpoints into our original integral, which was cosine to the power of 1008, 2x sine of 2x dx. So this cosine 1008 can be written as cosine of 2x all to the power of 1008. So let's just write this down over here for your information, guys. Cool. So from here, guys, let's write our integral sign and substitute in our endpoints. So instead of 0, we're going to write 1. And instead of pi on 4, we're going to write 0. Now from here, guys, it's easy to see that rather than writing cosine of 1008 2x, we're going to be able to substitute u in here and put that to the power of 1008. Now we're still going to have our sine of 2x here because we don't have a substitute for that. But rather than writing dx, guys, we're going to be able to substitute in this negative du on 2 sine of 2x. So I'm going to put that in a bracket. So from here, guys, what we're going to do is we're going to simplify our function that we have here. So to start with, I'm going to move the negative sign out to the front of the integral. I'm still going to have this u to the power of 1008. And what I'm going to be able to do here, guys, is this sine of 2x inside this square bracket, as well as this sine of 2x, will cancel out. So I'm going to move the 2 in the denominator underneath the u, and I'm left with simply du on the back. And this, guys, looks like a much simpler integral that we can evaluate. So before we move on, let's just tick off step 4 in our list of steps. So on to step 5, where we have to evaluate the new integral, which I've rewritten up here, guys, just to make it easier to follow. So to start with, we're going to just leave the negative out the front of our evaluated integral. We're going to open up a square bracket, because this shows that we're going to have a definite integral. We're going to increase the power on u by 1. So I'm going to have u to the power of 1009. And then I'm going to divide everything by this new power. So we have 2 in the base already, or the denominator, multiplied by what this new power is, 1009. Now this is like the anti-differentiation method of taking an integral. So this is what you should be learning when you first begin to start integrating functions. So I hope you guys have got that on lock already. We then close up our square bracket. We don't have to write plus c because this is a definite integral from 1 to 0. So the final step is the actual evaluation of this integral at the endpoints. We're going to keep our negative sign out the front. We've still got a square bracket because we have a definite integral. And now we're going to evaluate the integral at 0. So we have 0 to the power of 1009, which is still 0, over 2 times 1009, which is 2018. Not that it matters what the denominator is. Subtract, we're going to evaluate it at 1. So we have 1 to the power of 1009, which is still 1, divided by the same denominator, 2018. Close up our square brackets. Now what we can do here is we've got 0 minus 1 is negative 1 over 2018. But because we've got this cheeky negative on the front of the square bracket here, in exam conditions, I imagine there'd be a lot of kids who would forget that they put that here. So those two negatives, when we multiply them together, will give us a positive number. So we will get 1 over 2018, an important thing at the end, units squared. This is also very important, guys. You'll lose marks if you don't put the units in at the end. So you could have done all of this working out, and you'll lose 25% of your marks for not putting that unit squared on the end. So just before I go, guys, I'm going to quickly run through a few of the parts of this question which I think are the most responsible for students not getting the right answer. So the first one is forgetting to find dx. The second one is forgetting to evaluate the substitute at the endpoints of our integral. And the final thing, forgetting to put the units squared at the end of their answer. So again, guys, I hope this video helped. If it did, hit that thumbs up key, subscribe to my channel, do me a favor. I need to get this video in front of as many people as possible. So if you have any friends that you think may or could use a little bit of help with their u-substitutions, please share it with them. But until next time, guys, just keep practicing and practicing and practicing. These problems will usually follow the same sort of thought trajectory. So the more practice you do, the more fluent you're going to become at them and the less mistakes you're going to make going forward. So in short, guys, just keep on practicing, practicing, practicing. Try to avoid any of the common pitfalls that most students usually trip over. And most of all, enjoy your maths. So we're done here. 5 is ticked off.